Right, back with 100 Days of ML. It's day 81. Today I'll be reading section 11 of Statistical Modeling the Two Cultures by Leo Breeman. This is the last section. Almost. But pretty long. I'll try to get it done. Like if I can get it done today right now, I might as well finish section 12 and just wrap up this paper today. Okay, without further ado, I think I'm going to start. I'll just mute myself and then start taking notes on my iPad. And after finishing this section, I'll summarize it. Right. let's review section 11. It's pretty straightforward, to be honest. It's kind of wrapping up all the information that's been provided in the paper so far, and it just talks about how like it's a continuation of the previous section of the dimensionality issue, and it further talks about how it goes back to that section where people say that complex models are not able to be easily interpretable and therefore do not provide any useful information about the relationship between um, the the input and the response. However, in reality, it's more accurate at representing the nature of the function that's between inputs and outputs than any other smaller dimensional, smaller or less complex models. So, for example, he takes one of his projects that he's done with which has to do with, well, he describes two different projects in the section, but both of them are medically related. And for the first one, he talks about how he used logistic regression and that doctors could easily interpret logistic regression because of the simplicity of the model. However, when he used forests, it's not easily interpretable anymore due to its complex structure. But the ultimate goal that he says that it isn't really about interpretability, but it's actually the ability of producing accurate representation of the mapping between the inputs and outputs. For example, if logistic regression, although it's easily interpretable, produces an error rate of around like 22%, 30%, yeah? And when compared to forests, there's almost a 30% reduction in the error rate. So if you really look at what's producing accurate results, it's definitely random forests, regardless of the fact that logistic regression is less complex than random forests. We have to go with what's more reliable in producing that input-output relationship. So if random forest is able to predict that relationship more accurately, it's also producing accurate mapping between the inputs and outputs. And even if it is pretty hard to understand, we can always decode and deduce that, try to deduce that relationship to further analyze what variables are, being important and how exactly it's working. And so that's what he talks about. And it goes back to that topic that's raised up throughout this paper. It's the fact that less dimensionality doesn't necessarily mean more more interpretability. Because if you're interpreting wrong results, it isn't useful anymore. What's the point of interpreting wrong results? It might be easy to interpret it, but there's no use of interpreting it. And he shows that in random forests that when interpreting the medical results, there's a clear collision between what logistic regression thinks is important versus what random forest thinks is important. So we can see there that collision itself says a lot about like how using less complex models is not necessarily more useful. And then he reinforces his idea by providing another example with clustering in medical data. So the first one was just a prediction, but the next one, well, the first one is figuring out which variable is important. So through interpretability analysis. And for the second one, he's using clustering. And the same results occur. We can see that random forest is doing much better than the logistic regression, and the examples continue to provide a stable result of this difference. So finally, he just concludes. I haven't read the section yet, but I'll go ahead and do that right now. But so far, I guess the gist of it is the fact that, we shouldn't just automatically ignore more complex models just because it's not easy to interpret, because of the fact that it's able to produce reliable and accurate information. Okay, let me go ahead and finish up section 12 and we'll be done with this paper. Okay, so final remarks just concludes things. It talks about how, like, what the goals are in statistics. So it's necessarily to predict and get information from underlying mechanism. And he eventually goes over the fact that, people have just been attached to data models, and that's not necessarily the right attitude to have in the current day, especially when machine learning models are doing such a great job. And the immense amount of data that's produced on a daily basis. Although analyzing this type of data is kind of difficult, the analysis of generic data is one of the most challenging and interesting statistical problems around. It's like it's like focusing on data, but also at the same time we're trying to figure out how the model is able to produce a relationship between the data and the predictions or classifications or whatever your solution should be, what your problem might be. And so he finally concludes by saying that the statistics lie in working with data and checking theory data, and not necessarily just trying to simplify the model, keep it at a low dimensionality, and then use it to interpret it easily. Regardless of what the algorithm might be, whether it might be an algorithmic model or a data model, the important part is to figure out how it's able to represent that data and how it's able to map it to the real world. And yeah, over the past few years, statistical work has evolved to real world problems, and he believes that trend will continue, which is great. So with that, I conclude this paper. It was a wonderful read, honestly. I think I learned a lot about the fact that complex models are actually of value and of importance, because a lot of people, like, the popular word on the internet is the fact that simple might be better, or simple is better. But this paper definitely destroys that opinion by saying that what's the point of having simplicity if it can't accurately represent the relationship between two different things, right? You're just analyzing something that's just wrong. So it's super interesting to think about it in that regard. VRE. All right. So what do I do for tomorrow? Might pick up another paper and start reading it. Could be possible. Or I can do something else. Let's see what the next paper is. I'm kind of curious. Rashomon curves and volumes. Archive paper. Hmm. Ooh, this one goes over Markov chains. Oh, this one's a continuation of the Abremans paper. Rashomon effect can be useful for understanding the relationship between training and test performance. Oh, this is actually really interesting. I think I might actually start doing this. So let's do paper a week. Okay. I got the goal set out for tomorrow. And with that, I'm going to conclude for today. So I'll be back tomorrow. Thank you.